Well, the U of A continues to make incredible discoveries in space, and recently a University of Arizona graduate student led a team of researchers who discovered the most distant supernovas ever found.
Yes, so we know Krista DeCourcy, definitely the star behind all of this, the one with all the information this morning. So you are a grad student at the University of Arizona. Tell us a little bit more about your findings.
Yeah, so the previous record for the most distant supernovae ever found, they exploded when the universe was just around 3 billion years old.
Okay.
And we have found 40 that existed or exploded when the universe was between 1 and 3 billion years old. And so with the James Webb Space Telescope, we've been able to shatter all these records and really probe into the very distant universe and see what individual stars looked like when they explode in this time period when the universe has been around.
Wow.
So what's the significance of these findings? What does knowing what those supernovas look like and finding these distant supernovas allow you to do?
Yeah, well, with supernova explosions, that's the only way that we can probe individual stars at these distances. And so this is the first glimpse we're getting of individual stars. We can study galaxies as a whole, which are big clumps of stars and gas and clusters of stars, but this is the way we can study individual stars. And they can give us hints as to the environments that we're seeing in the early universe, which are very different than the universe that we see now. It's very different from the Milky Way and all of the galaxies around the Milky Way. The environmental conditions with the elements that were in the galaxies is very different. And so this is just our first glimpse of how many of these explosions are happening and the environments that they're happening in.
How long did it take you to kind of come up with these findings, or how long was this whole process?
Well, it all started with the James Webb Space Telescope, which has been in the making for decades, before I was alive. But the project itself started over a year ago because in order to find these explosions, you need 2 sets of images of the same part of the sky taken with some time apart so that you can compare the 2 images. I like to think of it like the game in a magazine where you see 2 very similar images and you need to find the subtle differences. In one image, the star hasn't exploded yet. In the other image, it has exploded and appears as a little white dot. And so you need enough separation between those 2 images in order to allow explosions to happen. And so once we had the first set of data, we needed to wait a year to get another set of data to even start this project. And so this has been going on since fall of 2022.
Okay. So you have some of your images here that you had sent to us.
Yes.
We'll just kind of let them play in this video. Can you explain to us, for the person who's like me and Carson, who knows nothing about what happens in space, what are we seeing in some of these pictures?
So the top row of images, in this top one in particular, you see 2022 images at the very top. And so that panel that says Z equals 2.845, that Z is just redshift. That's a different way of measuring distance. I won't get into that. But the top row shows images taken in 2022. The bottom row shows images taken in 2023. And so, like I said, there's that year of separation. And so if you look at that center column, you'll see a cyan arrow in the 2023 row at the bottom, pointing to a little white dot. If you go to that same spot in the top row in the center, you don't see that dot there. And so in 2022, the supernova wasn't there. In 2023, you see the supernova appear. And that's the kind of things we're looking for. And that one exploded when the universe was between 2 and 3 billion years old. And so that light, the universe is 13.8 billion years old now. The light we're seeing from that supernova is roughly 10, 11 billion years old.
And that is so small. So we know the James Webb Telescope, obviously, is it the most powerful telescope so far? Or
Absolutely.
No? Okay.
Absolutely.
So obviously weren't able to see things like this before the James Webb Telescope.
Yes.
But I would think trying to find that teeny tiny little dot, oh my gosh, that has to take so much time.
Yes,
Yeah.
it took me months to find all of these.
Oh my gosh.
What you do is you take the 2022 images and the 2023 images and you actually subtract them. Because galaxies don't change that much on a year-long time scale, and so they'll actually subtract all perfectly. So there's nothing there in this, we call it a difference image when nothing changes.
Okay.
But when a big explosion happens, it pops up as a dot in the difference image, and it makes it much easier to look at this pretty much empty image except for these little dots that are appearing. And so that's how astronomers find these supernovae.
Okay.
So what are we seeing in this picture? Those just those dots, some of those changes?
Yeah, so this time the top row is 2023 images, the middle row is the 2022 images, and the bottom row is those difference images. And so you can see there's a very bright supernova that exploded sometime between the 2022 and 2023 imaging, so it appears brightly in 2023 images in the top. not there at all in 2022. There is a star there, it's just so distant, and the star itself isn't that bright, so we can't see it at all. But when it explodes, it can outshine the galaxy, which is above it. And this one exploded when the universe was maybe between 4 and 5 billion years old. And so when you see it in that difference image, it appears very clearly, and it's much easier to find than when you have a huge image and you just have to see that there's a dot in one and that's not in the other.
Is it hard? I mean, me here, I know nothing about this. You're teaching me everything I know right now. For me, anything about space is so hard to wrap my brain around. You're talking about billions and billions of years old.
Yeah.
And the fact that this took you so long to find and nobody found it before the James Webb Telescope, is that kind of mind-boggling to you, or are you used to talking about this stuff?
It's absolutely surreal. I come from a unique perspective because I'm in grad school, so this was actually the first big paper I've worked on, and so
Okay.
I hear all these astronomers that have been in the field for decades saying how amazing it is that we're finding all of these. But to me, this is normal. This is you know the only time I've worked with stuff like this. But I do have to keep myself humbled and know that how unique this opportunity is and how people have been waiting to do this for decades and to find supernovae out to these distances. So it really is an incredible thing.
Yeah, and I think that, at least for me, I think about space, it's scary because I'm like, there's so much out there that we don't know about.
Yeah.
But aside from that, I think people wonder, what impact does this have on us here at home? So what are some of the things that you can do with research like this, and how is it going to propel you into more, I guess, space exploration and understanding of the universe in the future?
Well, one of the biggest confounding things that we've discovered so far with James Webb Space Telescope is that in the very, very, very distant universe, the earliest galaxies, there's some very bright galaxies, a lot of them, that we didn't expect to see. The theory doesn't account for why there'd be so many bright galaxies so far away. And so the supernovae can help answer that question. The next step in this process is to figure out the rates of supernovae at various distances. And so if there are more supernovae explosions at further distances than previous theory would suggest, that could explain why we're finding so many bright galaxies. There's so many more stars exploding in them than we had expected. And so that's one of the biggest scientific questions that James Webb has brought up, is why are these very bright galaxies so abundant in the early universe? Maybe we can finally answer that question if we discover that the supernova rates at early times are higher than what we would expect.
Wow. So
Both of us,
we're like, wow.
Wow.
So what's next here? Are you guys just going to continue to try to find more of these stars that have exploded, or what are your next steps in the study?
We're going to try. We need more data to do
Okay.
that. We just have these 2 sets of images. I'm going to keep looking at the images to see if I can find even more distant ones. This was just the first sample paper that I put out.
Okay.
Again, we'll do the rates. There's individual objects that are very interesting that we can do just detailed studies on single supernovas or
Okay.
supernovae that exploded. There's 10 different directions you can take this in.
Yeah.
And we're going to try to get more data. We're going to try to get a third set of images for this field to see if we can find even more that are exploding even now. And just keep finding more and keep building our sample of early universe supernovae.
Okay. Is there anything else that we didn't mention that you want to talk about with the study, or any other little details?
Just a fun thing to really connect supernovae with people. We're made of carbon, amongst other things in the universe. Or the Earth itself is made of iron and a bunch of other elements. These elements all come from stars. They are fused in stars. And if it wasn't for supernova explosions, they'd be stuck in stars. And so it's these supernovae explosions that release all of these elements into the universe that then can form planets and can form life. And so every element in my body and in your bodies came from within a star.
Wow.
We're star girls.
Oh no.
I kind of love that. Wow.
And so the supernovae we're seeing in the early universe could, at this point, we're seeing the light as it existed billions and billions of years ago, could be in people somewhere else right now. And that, I think, is a really neat thing to think about.
Do you think there are people somewhere else?
Absolutely.
Absolutely.
I do
Okay.
too.
I hope you find them. I hope you're the one who finds them.
I hope so too.
Yeah.
Awesome.
Well, thank
you
you.
so much,
Thank you.
and congratulations. This
Yeah.
is such a huge accomplishment.
Thank you.
Yeah.
You're
Thanks for
welcome.
being with us. Keep us posted on
Absolutely,
your
will do.
research. Appreciate it.